Okay, so we're going to just practice and try to get a feel for two sample proportions versus two sample means versus matched pairs by writing the null and alternate for several different selections. We're going to determine which test are we going to use, and then we're going to write the null and alternate. So our first little scenario here is the question is, you've got two routes to work. Is route A to your work faster than route B? I was trying to get to the highlighter, right? Because there's the question, and that's really going to guide our alternate hypothesis, right? So we're going to flip a coin to determine which way you go each day, and you drive each route 20 days. Okay. So you're going to ask, first off, is this means or proportions? And since we're talking about time, we're going to say it's means, right? Because time is going to be a quantitative variable, and it's going to use a mean to summarize. Okay. We know that there's two means, and then the question is, so we've got a group of route A times and a group of route B times, and the question is there any sort of link between the two of them, right? Like if I pick a particular day from the A route group, does it link to any particular day in the B route group? We're going to say, no, I don't think so, right? So this one's going to be a two sample means problem, all right? So two sample means, which means our null is just going to be that route A, the mean for route A is equal to route B, right? Because the null is always that there's no difference, that the two things are the same. Now our alternate is going to come from the question that I highlighted. Is route A faster? And this is a little tricky, right? Because you got to think about time. Faster means less time. So that means our symbol in the middle is going to be a less than, because it's faster. Okay, so and that's as far as we're going on these, right? So our next one, company institutes an exercise break for workers to see if it will improve job satisfaction. Scores for 10 randomly selected workers before and after implementation are recorded. Okay, so we look at this, and we're talking about scores, which is probably a means problem. But we also see, before and after. So we have two sets of measurements on each person. Two measurements on each person, right? So that means, right, you've got person number one, they've got a before exercise break satisfaction score and an after exercise break implementation satisfaction score. And so we could calculate the difference there for each one of our workers. This is a matched pairs example because our samples are related, right? Right here you see before and after. That is a dead giveaway that we are matched pairs, that they are dependent samples. Okay, so that leaves us just with having to write our null and alternate, right? Well, we're going to start by saying, hey, which order do we want to subtract stuff? Well, it's up to you. It doesn't really matter. Most people will default to seeing a positive number be the thing they're looking for. So we want to see that the exercise break improves job satisfaction. So we would probably say, let's say after the exercise break is implemented minus before. So that's going to be our difference variable, right? We're going to go through for each person. We're going to subtract those scores. And our null would be that mean difference would be 0, right? That over everybody, average over everybody, that there's no difference in job satisfaction on average. The alternate, we got mu d, we got 0, and here because I subtracted after minus before, we think the scores will be bigger with the exercise break than without. So we think that this difference should be greater than. Okay. And I think that let's break here. I do have some more examples. I'm going to just throw them all at you guys, but let's break.